Hello and welcome to our multimedia training. Today we will cover the Transfer Blazer FTB81XX series using it as an SDH and OTN analyzer. So we will talk about the product and then have some testing application and testing configuration on the GUI itself. So the product, as I said earlier, will be the Transfer Blazer, and we will talk about the testing applications on the legacy and also the OTN, OTU1 and OTU2 applications. And we will also have on our unit itself an STM64 test case and also an OTU test. On this slide we have the different flavors of the FTB81XX series. On the top left we have the first module, which is the FTB8115. That one does testing from 64K all the way to 622 meg, basically from E0 all the way up to STM4. Right below that we have the FTB8120 that does testing from 64K to 2.7 gig. So that one covers E0 all the way up to STM16, and also it does OTU1 testing as well. Below the FTB8120 we have the FTB8130 that does all the testing that the FTB8120 does, and also it does testing for STM64 and also OTU2. Below the FTB8120 we have the FTB8120NG that does all the testing that the FTB8120 does, and also it does Ethernet add and drop testing. The FTB8130NG is the module that does all the testing from 64K all the way to 10.7 gig, doing testing from E0 all the way up to STM64 and OTU1 and OTU2 as well. It also does testing for Ethernet add and drop. Now we have to realize that even though we have the testing option for next generation on FTB8120NG and the FTB8130NG, those options can only be used on the FTB400 platform. They cannot be used on the FTB200 platform. On the right hand side we have a faceplate of an FTB8130NG. The Bantam and the RJ48 port are used for the E1 testing. The BNC port is used for the E1 all the way up to E4 testing, and STM electrical as well, which are the STM0E and the STM1E. The auxiliary port is used for the dual E1 and E3 testing, combining with the Bantam or the BNC port. It also can be used as a clock port for input and output. On the top part we have our optical port. The first one is used for 155 meg all the way to 2.5 gig testing, basically from STM1 all the way up to STM16 and also OTU1. It also supports multi-rate SFP transceiver. Right next to that we have our 10 gig port, which is used for the STM64 and the OTU testing. The type of transceiver that it accepts is the XFP. On the top right corner we have our Ethernet port, which are used for the add and drop. The electrical port is used for 10, 100 and 1 megabit Ethernet port, and the optical port is used only for 1 gigabit Ethernet, and it supports in SFP as well. The external reference output is used for mainly lab application for 10 gig testing. Now, the Transfer Blazer module supports PDH testing going from E0 all the way up to E4, and also it does STM testing from STM1 all the way to STM64. So basically you can have your STM1, STM4, STM16 and also STM64. It also supports optical transport network testing, OTU1 and OTU2. Some of the advanced testing applications are the Smart Scan that we will explain later. And this module is upgradable. So if you have, suppose, an FTB 8130 that does not support the next gen feature, it can be hardware upgraded to support those features. So on this slide, we will talk about some of the testing applications that we have on STH legacy side. First, we will talk about the continuity test, and then we will have the bit error rate test. We will talk also about how to sectionalize error on the network, how to do signal detection, and also how to do alarm and error processing. We will also talk about the round-trip delay measurement. We will see how synchronization works on the network and how it can be tested on the unit. And last, we will talk about protection switching. So first, the continuity test. What is it? It's a basic test performed just to make sure that we have an end-to-end connectivity. Why is it used? To verify the compatibility of framing, coding, synchronization with different network elements. And how is it done? Basically, it's just to set up an equipment on each end and just to verify that they connect and talk properly to each other. So you can just send a trace, a G1 trace for instance, and make sure that it's received on the other end. As we can see on the diagram here, so we have from one test set to another test set, we have a signal that is sent, and we can send a trace. So the test set on the left hand side can just send a trace, and we can make sure that that trace is received by the test set on the right hand side. The next testing application that we will talk about is the bit error rate testing. So basically, this is just an out of service test, just to make sure that we have a qualification of the payload carrying the STH circuit. Now, how is it performed? Just by sending a PRBS, a pseudo-random bit sequence that fills out the payload of the testing signal. This is a test that usually runs for a long time, between 12 and 24 hours, and we monitor it and just make sure that there is no error on the network. Now, why is it performed? To qualify services before it's handled to customer, to troubleshoot problems on specific circuits, to identify physical and STH layer problems, and to test the full payload of the service using concatenated signals. As we can see on the diagram here, we have different networks that we have a point-to-point configuration and a ring configuration. So we can have on top, on the point-to-point, just have a bit error test running for a long time, have a loop back, and just make sure that we don't have any error. And the same thing applies to the one at the bottom, where you can have different test set, or you can just have one test set and then looping back from one of the network element. The purpose is just to let the test run for a long time and make sure that there is no error on the network. The next testing application that we talk about is the error sectionalization. So basically, this is just to help identify the exact fault location on the network. How is it done? Just by using the bit error, the B1, B2, and B3 overhead errors, and to help us identify what the errors are located on the network. Now, why is it done? To identify which part of the network is in fault, and to determine error locations in amplifier chains. As sometimes having large and complex network can lead to a long time to identifying what the error is. So by using the error sectionalization method, it reduces that time considerably. Now, on this slide, we will talk about our signal auto detection mechanism, which we also call the smart mode. So basically, this one allows us to discover any type of optical signal and see exactly what's inside of the signal. So we can also use that to start a burst test. Now, how is it done? By using the signal auto detection feature of the transfer bezier and scan the incoming STH signal and displaying its content and its mapping. It is used to determine the content of the signal of the network handoff point to point between two services, to start testing a specific tributary according to the detected signal structure, and to analyze the provision bandwidth in the network. The next testing application is the alarm and error processing. So this one is designed to allow for transfer equipment between different vendors to work together. So however, the perfect interoperability is not always achieved. In those instances, it's sometimes necessary to test the ability of the network to properly process and forward errors and alarms. Basically just to make sure that we can have different alarms and different error processes between different network elements from different vendors. How is it done? The testing is best done in a lab environment before it's handed over to the customer. And the testing functionality is accomplished by manipulating and monitoring various bytes in the SDH overhead and verifying that both errors and alarms are reported throughout the network. Our next testing application is the round-trip delay measurement. So basically in this one, the transfer bridge sends a signal over the network and see how long it's going to take for the signal to be carried over the network to come back to it. As you can see here, there's a signal coming from our FTB81XX. It goes to, there's a physical loopback, a software loopback, and then it comes back to it. So that gives us the round-trip delay measurement. The next application is the synchronization or pointer adjustment. This is used to test the timing and synchronization of the STH network. It is done through analysis of pointer activity, through monitoring the H bytes in the line overhead. Some minor pointer adjustment may be expected, but excessive adjustment may be indicative of incorrect timing configuration. Why is it done? One of the greatest advantages of the STH obviously is its synchronous nature. So if an STH network is experiencing timing problems, the pointer byte will try to compensate. And if the pointer byte cannot keep up with the payload movement, then the payload may be lost and the error will be start to piling up. Automatic protection switching and service disruption time measurement. So this is a very critical testing application for a lot of STH or most STH networks. So on top, as we can see, for the an example where we have the automatic protection switching time set to less than 50 milliseconds. So we can measure that protection time on the test set. If, let's say in this example, there's a fiber cut on the protection, the time is going to take to switch back to the working, so we can measure that. So now, on the next part of the presentation, we'll actually talk about our OTN or G.709 testing applications. Some of the applications are alarm and error stress, mapping and demapping of the client signal, FEC behavior testing, and some field testing applications. The first type of test for the OTN, the optical transfer network, is the alarm and error stress testing. So basically in this test type, we inject some alarm and errors through the OTN network element, and we verify that it responds properly to the test. So this is usually done in a lab environment. So you can measure loss of signal, loss of frame, bit errors, as you can see on the diagram. So we send an alarm on the transmit and we expect the alarm on the receive end. The next application is the mapping and demapping. So just to make sure that our OTN network element can properly map a client signal. This also is done usually in a lab environment. So in this example, for instance, we have an STM64 signal going into our OTU2 layer, and then we'll make sure that it is mapped properly, and then we'll expect that to be received on the FTB81XX. Our forward error correction testing. That is used to generate and measure correctable and uncorrectable FEC errors to verify proper FEC functionality. This is usually done in a lab environment. So in the example below, the FTB81XX will send some FEC error, and they should be corrected by the G.709 network element. So on the receive end, the FTB81XX should not receive any FEC errors. Now, some testing application, the main testing application is usually for troubleshooting on the network. So we can drop one wavelength at master point and verify that the OTN signal integrity. So now we will move into the second part of the presentation, which actually will be done on the unit itself using the GUI of the unit. When we first launch the FTB200, this is the screen that appears. In order to launch the FTB81XX module, we click on the Start button. This operation actually will take a few minutes to come up. Now on the screen we have the GUI of an FTB8130 module. As we can see, this is the application that we actually use to configure our test case. We have the GUI where we can select the type of test that we want, and also we can run the test. On the first part, we will select an STM64 test case in which we will have an E3, and inside the E3 we'll also select a specific E1. So in order to select our STM64, we click on ports, and that will give us an option to choose the different rates that we have available on the module. As you can see, we have different rates available here, so we can click on more, and that will give us all the rates that we have available. Now this is a module that has all the options enabled, so not all the rates will be displayed on the units that you actually have. So the rates displayed will be based on the type of module, and also will be based on the software option that you have purchased. So I'm going to select an STM64 rate, and this will configure my 10 gig port to be ready for the STM64 test. Now on the screen we have a diagram that displays the path and the hierarchy that we are actually using. As we can see, we have STM64XFP. That means that we're using our 10 gig port, and it requires an XFP transceiver. So from there we select our path, we click on path, and it's going to give us more details on the hierarchy and the choices that we have. So from the if I click on more, on my high order path, it'll give me the options that I have. So I have from AU3 all the way to AU464C. So we're going to do, for this test, we're going to select an AU3 test case for our high order path selection. So it's going to configure and update the HOP for AU3 test. Now as we can see on the screen, we have different AUGs that we can select. This is done in a type of matrix, so you have to know exactly which AUG16 you're going to select from the drop down menu, and also which AUG4 you're going to select, and also the AUG1 that you're going to select. So for instance, if you want the third AUG16, and then from there you want the second, let's say the second AUG4, so you select AUG16 on the drop down menu, you choose 3, and then on AUG1 you select the second one, and then from the AUG1 then you make your choice for the AUG1 that you want to choose. So for this example, I'm going to choose AUG4, and that is the hierarchy that I want within my AU3. On the right hand side, we have our low order path selections. So as you can see on the screen, we have TU2, TU12, and TU11. For the sake of the test that we're doing right now, let's select TU12. So I'm going to click on that, and it's going to update the configuration for the low order path selecting TU12. Now as you can see, I have my TUG2 and my TU12 that appears here. So I have choices to make from 1 to 7 TUG2, and also for my TU12 I can select a specific one. I can also enable my tandem connection monitoring on both my high order and my low order path. On the diagram above, as you can see, the TU12 has now been added. So I'm going to continue in my mapping structure and select an E1 to go inside my TU12. So it's going to update once again the mapping configuration to select an E1 inside my TU12. Now as you can see, we can configure our framing for our E1 here. So we have our pulse code modulation here from 30 all the way to 31, and also we can have our framing being set to unframed. We can also enable E0 and do E0 testing within our E1. And if you want, we can modify the content of the payload of our E0 channels here. So if I click on payload contents, it's going to display the 32 channels that we have under our E1. So we can set the pattern to specify one, or we can make it idle if you want to. Now we're going to click on the test pattern to specify a specific PRBS that would go inside our E1. So we have different choices here, from PRBS 2 to the 9 minus 1 all the way up to 2 to the 20 minus 1. We can also have it a user defined if you want, so just basically to set it as any type of PRBS that we want. We can have live traffic, and also we can invert the PRBS that we're receiving. This concludes the part of the configuration of the test case itself. As you can see, it shows us the full diagram here of the test case that we just configured. So at this point, we are ready to start the test by just clicking on the start button. So I'm going to click on the file menu on the right hand side. As you can see now, we have different options. We have new, that's to create a new test case, to clear the test case. Open, if you want to open a configuration. Save as, to save a configuration, and report, and also the about tab. The testing function themselves will reside under the test menu. So if I click on test, it'll bring me to a sub menu that has port, SDH, where my SDH layer testing functions are, DSN where my PDH testing function are, pattern, and some advanced testing. So I'm going to click on ports. So this is going to take me to the configuration of the port itself, the physical port. As you can see, we have two tabs here, port TX and port RX. The port TX shows us the type of connector that we use in the transceiver basically. As we can see here, since we're using the 10 gig port, it shows the XFP transceiver. It also shows us the wavelength that is displayed here. So this will be probably a good idea to start. If there's an error or there's an alarm, we can check here to see if the wavelength that we're using is matching actually the wavelength of the signal that we're expecting. So we can also generate loss of signal alarms here by just enabling it here, and also we can have a frequency offset set. So for instance, if you're using a test where we have some timing issue where the frequency offset is a little bit off, so we can modify that here. So below that we have the actual frequency that we're transmitting is displayed here, and also it displays the nominal frequency. On our receive tab, so this displays also the XFP, the interface that we're using, and it gives us the power level. So if you have any LOS or any frequency, that would be displayed here. So I'm going to start the test so we can see an input power level. As we can see right here, we have the input presence LED that is green. So that means that we are receiving an input signal. as we can see, the test has started now, and we have a power level. So right now it's displaying -10, -11 dBm. So that's the level of the receiving signal power that we have actually. And also our receiving frequencies here, as well as the frequency offset, positive and negative offset frequencies. So we're going to go further down the menu under the test configuration. So to go to the SDH layer, so we click on SDH, and that's going to bring us a new sub-menu. So the RS is for our regenerator section, so I'm going to click on that. So it's going to basically display all the overhead that applies to our regen section. So any alarm or any error that we can receive or inject on the regen section would be under this sub-menu here. So as we can see on the left hand side, we have several tabs. So here, that's if you want to generate an LOF alarm, for instance, a loss of frequency, this is where we'll do that. And also if you have a B1 error that we want to inject, so we can do that. We can do it at once by just sending the amount, or we can do it continuously by just clicking on here and turning on the on-off button, so it will send a continuous B1 error. We can also do a trace. This can be used to do continuity test, for instance, where you can send a trace from one end and make sure that it's being received on the other end. So likewise, RSRX tab, which is the regen section receive tab. So this will display any alarm that we have or error that we have on our regen section layer. So as you can see, out of frames, loss of frame would be displayed here, as well as any received B1. So if you have a trace that we receive, it's going to also be displayed here. The overhead transmit of our regen section. So this is where we can change and modify our overhead byte. As you can see, you can select the specific STM channel by clicking on the drop-down menu. It gives us the list of all 64 channels, and we can go select a specific one and then modify the overhead bytes. As you can see, the A1, the B1s, and all the other bytes can be modified here. On the overhead receive tab, so this is where it will display to us all the receiving overhead values. So this is for any channel that is selected under the 64 channels of the STM64 signal. Next to the overhead RX, we have our PM tab, which is our performance monitoring tab. So this tab is used to monitor the performance. So the standard that is used here is the G.829 ISM standard. As you can see, this one does only the near end. So we have some errors that are monitored, for instance, are error-free second or error second. So right now, if you look at the error-free seconds, for instance, the value is incrementing. So that means basically that for the past 239 seconds, I've been running a test error-free. So these are the tabs or the functions that we have under our regen section. The next menu under the test, under the STH menu, the next sub-menu is the MS menu, which is the multiplexing section. So here we would see all the alarms and errors and also the overhead that would apply to that layer. So as we can see, when we click on that, we have several tabs that appear. The first one is the MSTX, which is the multiplexing section transmit tab. So under that, if you have any AIS that we have to generate, for instance, on any remote alarm that we're receiving or expecting, so this is where we actually inject or generate those. And also this is where we would inject our B2 error that only applies to our multiplexing section. So we can do it just like the B1, just one specific amount, or we can send them continuously. The MSRX is the multiplexing section receive end. So basically the same type of alarm that we inject, we expect them here as well. And also this is if you have any B2 error, any REI error, those will be displayed here. It will show us the duration and the counts and also the rate at which we are receiving the alarms or the errors. The overhead byte, that's under the overhead TX, that's for the transmit. So this will, just like on the region section, allow us to select a specific channel, a specific STM1 channel under the STM64 and modify the overhead bytes. So as you can see, we have all the overhead byte that applies to that layer that are displayed here, and we can modify them here. Right next to that tab, we have the overhead RX tab. So the same overhead that we can modify on the TX are displayed here when we receive them. As you can see, the values of the overhead bytes are displayed here. These are the values that we are receiving. Next to that tab, we have the Advanced TX tab. So the Advanced Transmit for our multiplexing section. So this is where you have overhead for our SS bits, for instance the H1 byte. So those can be modified here, and also our synchronization used mainly for our timing also can set here. As you can see, we have several choices. Some, for instance, if you have the quality of your signal is unknown, or going down to don't use if you don't want to use any type of synchronization. So you have different bytes and different values that can be set for the specific bits. Below that, we have our automatic protection switching mechanism that can be set here. If you want to use linear type of, if you're in a linear network or if you're in a ring network, so you can choose your selection here, and then based on the type of choice that you make, then you can change your K1 and your K2 byte values. If you have no request, for instance, you can set here, or you have different choices going from no request all the way down to a lockout of protection. If you don't want any type of protection, you can set it here. So as you can see, we have different choices here. You can set a specific channel here for your protection. You have all 16 channels, so you have the choices here. This is where you would do that. So once you've selected your channel, so the K2 byte drop-down menu for protected channel will also allow you to select the specific channel under the protect. So if you want to modify your architecture, if you have, depending on the number of network elements you can have 1+1 type of architecture set, or you can have 1/n architecture set. The operation mode also is set under the operation mode, where you can have your K2 byte bit set here, so for reserve, for instance, or unidirectional, bidirectional, depending on the configuration that you're using on your network. On the Advanced RX tab, so basically all the bytes that we are able to modify on the TX, so we can see the values here if we are receiving any. For instance, the H1, the SS bits of the H1 byte are displayed here. The last 4 bits of the H1 byte also are displayed here, so we will know exactly the synchronization status that we are receiving. So also, if you know the type of switching mode that we have, so we can select it here and see if it gives us the right values. The K1 byte and the K2 byte value are displayed here as well. The last tab is the Performance Monitoring tab. As we can see, we have under that we have 2 types of standard that we can use, the G.829 and the M.2101 standard. So those standards will allow us to do measurement both for near end and the far end. So as you can see, we have the same type of basically error that we could performance that we could monitor on the RS, except for this time we can do it for the near end and for the far end as well. Below the MS menu, submenu, we have the HOP, the high order path submenu. So that one gives us the options to modify any overhead bytes that applies to the high order path, and also to inject alarms and errors that are specific to that layer. So as we can see, the HOP-TX tab gives us the option to generate some AIS just specific to the overhead path, and also we can do B3 and error continuously or once. This is also the place really if you want to trace the continuity over your whole signal from end to end. This is where you would do it by injecting, for instance, you can have a trace here send a message, I'm going to type. If you click on the message here, so this is very useful for a continuity test. So if you type so this would allow us to send that message, and then we have the format, so you can have a 16 bytes or a 64 byte format depending on how long you want your text to be. And on the HOPRX tab, so this is the high order path for the receive end. So this is where any alarm specific to that layer would be shown to us. As we can see, we have our AIS, our LOP, LOMs, and RDI just for the HOP are displayed here. And also we see we have our B3 error here. At the bottom, as you noticed earlier, under the TX, I sent a trace, and that trace is received here. So that means that I have a continuity on my network. The OHTX tab, that's the tab that allows us to modify some overhead byte to the transmitting. So we have our C2, G1, F2 here. That's just one of the bytes. And also we can change the label of the path here. So we can change the structure of a TUG, for instance, and we can do a lot of other modification going down all the way to reserving, if you want, just a specific frame. And also if you want, for instance, a synchronous mapping, if you be using that, we can also do that here. On the receive end of the overhead bytes, that's the OHRX. So as we see, if you receive any of the overhead byte value that we're receiving just for the high order path, those values would be displayed here, and also the structure of the label that is displayed, and also the path. The PTR-TX, that's the pointer adjustment on the transmit. This is where we do the pointer adjustment. So if you want to increment our pointer value, so we can set the steps here. If you want to decrement the pointer value to a specific location on our frame, you can do that here. If you just want to jump directly to a specified location, we can do here. And also we can have NDFs, new data flags, also here. So we can send them all, so we can specify our values and then modify them here. Likewise, on the PTR-RX is set for the pointer receive. So it will give us the value of our current pointer. If we have any offset, it will be displayed there. And also give us the increment, if you have any, the decrement, and the duration of those increment, decrement. If you have new data frame or no new, so those will be displayed here as well. Our TCM-TX, that's for the tandem connection to transmit on the TX. So this is where if you have any tandem connection monitoring, so if you have any alarm that you want to generate for that, so this is where we would do it, or any error that we want to inject also will be done here. If you have a specific identifier, a message that we want to set, just to make sure that we have an end-to-end connection on the TCM end, so we can specify the message here and see if we receive that on the other end. The TCM-RX tab displays basically all the alarms and error that we receive on that layer. So if the message also will be displayed here, as you saw earlier on the previous tab, it shows X4, that means that I have a connection on my TCM. The PM tab is the performance monitoring just for the HOP layer, just like the MS PM. So we have also the measurement on the near end and on the far end, and it uses G.828 ISM as well. So you have, for instance, EFS, so that means that for the past 872 seconds we haven't had any error. So these are the tabs that apply to my high order path. Right below my high order path I have my LOP submenu. So this is the low order path submenu. So there we have different functions as well and different tabs as well. So we have our LOPTX for the transmit, where we can generate and alarms and errors. So we have the AIS just like we did on the high order path, and the beep errors that we can do. We can also do a trace, but the trace is going to be just on the low order path. So we can do that here as well. If we receive any alarm or any error on that path, on the low order path, it would be under our LOP RX tab. So this is, as you see, if you have any AIS, any LOP or RDI, for instance, would be displayed here. And also if you receive any trace just on that path, it would be displayed here, just like it was on the HOP tab. The overhead TX, the OHTX to transmit. So this is where we would modify our overhead bytes for the LOP. So we can set different values for our overhead byte, and also we can set the signal label path just like we did on the HOP. And also the overhead RX. This is where we can set the expected path, for instance. It would show us the overhead values. As we can see, our V5 keeps changing, which is normal. And also we have the other overhead bytes that applies to that layer displayed here, and it's going to show us the value. The rest of the tabs are exactly the same as the high order path tabs. So the next testing function that we have on this are actually the test under our DSN PDH. So I'm going to click on that on the DSN PDH menu, and it's going to bring us some new submenus. So this is where we have our E0. So if I click on E0, it's going to bring some new tabs that all apply to our E0 layer. So we have, this is where we actually modify, select a specific channel, E0 channel, and modify that. Select the type of load that we want to put inside of there, if it's specific pattern that we want, or if you want just to have it idle. We can also have a tone set that we can put in that context. In the EORX, that's for E0 receive end. So if you have the content of the payload will be displayed there, as well as the type of payload that it is. So this only has two tabs, one for transmit and the other one for receive. The next submenu under the PDH is actually our E1 submenu. So this is where we have our E1 TX and our E1 receive, and also the performance monitoring is out there. So if we have some spare bits that we want to modify, so we can do that here. As you can see, select a specific bit that we want to modify, and also if you want to inject any AIS alarm or inject any FAS alarm for error, for instance, we can do that here as well. We can do them at a specific rate, just like the other errors, so we can just do them continuously. Any defects that's received on our E1 layer would be displayed under E1 RX. So as we can see here, the specific alarms that we receive, if you receive any, would be displayed here, the LOF for instance, and also if you have any error, it would be displayed on this screen as well. So if the bit that we receive, the spare bit that we're receiving, as well as the framing that we have, would be also monitored right on this screen. The PM tab for the performance monitoring, just like on the STH layer, can be displayed here. We can see some of the same type of defect that are measured here. So we have the near end and also the far end measurement that is done here. So this concludes the part of our PDH portion. So if you click on back, it's going to take us to the testing menu again. So we have the next menu is the pattern. So this is where we can modify, for instance, our test pattern. So it brings us to different tabs. So we have our pattern, transmit and receive, and also performance monitoring just on that layer. So if you want to modify our PRBS, for instance, we can do that just like we did it when we were configuring the test case. We could do that here. If you want to generate any pattern loss or inject any bit error, we can do that on this screen. If you receive on the receive end, so it's going to show us the PRBS that we're expecting. And also if you have any pattern loss, any bit error. So if you have, for instance, a pattern loss, we know that we can go to our PRBS receive and modify that, for instance. And also if you have receiving any bit error, it would be displayed here. The PM tab is for the performance monitoring, and we only have it for the near end on this one. So these are the three tabs that are actually available for our pattern submenu. The advanced menu allows us to actually do testing for our service disruption time measurement and also our round trip delay measurement. As we can see here, the service disruption time, we have different options here. So this is where if you want to measure, for instance, the time that it's going to take our circuits to go from working to protect when we're doing an automatic protection switching test, this is a good way of doing that. We can select the layer that we want to test. So we can, for instance, it's going to be a bit error that we are monitoring, so we can go to pattern because the bit error are available under that layer. We can select that layer pattern, and then we can choose under defect selection bit error. So below that we have the no defect function. Basically this one gives us the minimum amount of time that it is allowed for the unit not to detect that error. So we have it, if I set it to I'm going to change the unit to milliseconds, for instance. So this one is set to 10 milliseconds. I'm going to change it to the value to 50 milliseconds. So I choose 50 and I hit OK. So now I have my no defect time set to 50 milliseconds. So basically, if I'm running a test and I have a bit error that doesn't last for 50 milliseconds, it would not be counted in this screen, so it would be ignored. So if this is very useful if I'm doing an automatic protection switching measurement, so then I'll know that if this one shows me an alarm on an error, then that means that it's going over my protection switching time. So then this is the test period. This is the duration of the test that I want to run basically. So to enable it, I just have to click on the on-off button, and it's going to give me the statistics. So right now I don't have any bit error. So I'm going to inject one bit error. So as we can see, the count is 1 here, and also it gives us the duration. So it lasted for about 5 microseconds. So this is very, very important and it's very, very useful, especially to measure and to determine APS switching times. The next tab is the round trip delay measurement. So basically this tells us how long it's going to take a signal to go across the network and to come back to the test set. So we can do the measurement two ways. We can do it single mode, meaning we only send one signal and receive it, and that's it. It only does it once. Or we can do it continuously. So basically it's going to keep on sending a signal. If you know that, you can do that. If you know that you have a network that at times are congested or you have traffic at different times, so you can run this, and then it's going to give you the statistic. How long, what was the minimum delay, what was the maximum delay, how long did it last, the average delay, and also you can set the units here. It's going to tell you the successful, how many was received back and how many failed, meaning how many you didn't receive. So this is a tool that is used to measure the round trip delay. These are the functions basically that are available under that type of test that we did, and these are all under the STM, any type of, we just did the STM64 test, but any type of test that you would do for the optical or even on the other ports, we would have all these functions available for them. To clear the test, we will go back to the main menu by clicking on Main, and then File, and then we'll stop the test. And then we have now different menus under the main menu. So we click on New, and that'll give us the option to actually clear the test. So say yes. So this will clear the configuration that we just created. So it's ready for a new test case. Now let's configure an OTN test case on this unit. As we see on the GUI, we have the option to choose the port that we want to configure. So I'm going to click on port, and it gives me the different options of rates that I can use. In order to get to my OTN, OTU1 and OTU2, I click on more, and it's going to display all the rates. Now, these are the rates that are actually enabled on this unit. Not all units would have these rates because some of them do not support all the rates here, and also some of them do not have the software option enabled. So we have to have the hardware to do the test and also the software option to do the test. So I'm going to perform an OTU2 test. So I'm going to select OTU2, and it's going to configure my 10 gig port. As we can see on the left hand side, we have the different options for my OTN testing. So if I click on, so I see here the connector type that is being used, that's the XFP. And also on the right hand side, so this is where I actually can use my OTU2 layer itself. So we can enable our forward error checking, or we can enable our scrambler if we're doing scrambler testing also. So my ODU, my optical data unit layer, so the options that I have there are displayed here. So I'm going to select an STM6. I have choices between STM64C192 if I have those options enabled, and also I can do an ODU1 or ODU2. So I'm going to do an ODU2. So it's going to update the configuration, which will take a few seconds. So now I have a specific ODU that I selected. I selected ODU2, and I can also do tandem connection monitoring within that. So I click on that, and it's going to give me an option to select between from 1 all the way up to 6 monitoring points if I want to do some monitoring. So I'm just going to select, for the purpose of this test, 3 monitoring points, and I just click OK. So now I've enabled 3 monitoring points. So I can set my test pattern here, the pattern that I want to use within my ODU2. So I have different rates here, different pseudo-random binary sequence that I can use. As we can see, if I want to make my selection, I just click on the drop-down menu. I can even have a user pattern that I'm defining myself. I can use it under live traffic, for on the transmit rate, on the receive end, and also I can invert the PRBS that I'm sending. This is how to actually perform a configuration of an OTU2 ODU2. We have different scenario, different type of sequences that we can use, but this is the one that we have chosen for this type of test. Now, to actually see the options that we have for the test, the features, we click on test. So this is going to give us the option to actually see our port layer. So this is the physical layer itself. The port TX would show us the type of transceiver we have, the interface that we are using, and also the transmit wavelength. And also this is where we can generate some LOS alarm. And if you have any frequency offset that we need to do, for instance, if we have some timing issues or timing differences between our test set and the network element that we're connected to that will cause us to change the offset, this is where we'll do it. The actual frequency and the nominal frequencies are displayed here as well. On the port RX tab, so this is going to show us the type of transceiver that we're using as well, and also if it's going to show us the power level. Right now we have the input presence LED that is green. That means that we are receiving a signal. So if I click on the start button, so that's going to give us also the power level of the signal that we're receiving. So this is a good way to see if we have a high or low level. Sometimes if you have some LOS error or LOS errors that we see, maybe it's because of the power level of our signal. So this right now is showing us about a negative 11 dBm. So that might mean that based on the signal that we receive, that we might need some attenuator, or we need to change our fibers, for instance. And also if you have any LOS or frequency alarm, this is where they will be displayed. Below that we have our frequency, And also if you have any frequency offset, it will be displayed here. It would show the maximum positive and maximum negative offset frequency. Now let's go back to the test menu and let's select our OTN submenu, which shows us the testing functions for the OTN layer itself. So if you click on that, we have our OTU2 sublayer, we have our FEC sublayer, ODU2 and ODU2 and OPU2 sublayers here as well. So the forward error correction testing, if you're doing that, we click on our FEC sublayer, and so we have it for the transmit and the receive, FEC transmit and FEC receive. So if you enable FEC, so we can send some forward error correction, for instance. We can do this if you're doing some alarm and error testing. We can inject an error here, or we can do it at a specific amount, or we can do it continuously. Any FEC error will be under the FEC RX tab, so it will show us the type of error that we have, and also it will show us the duration and the count. So this is once again very useful, especially in the test where we're doing some alarm and error testing. The OTU2, the optical transfer unit layer, the OTU2 submenu, if you click on that, it gives us different tabs as well. So this is where we will also inject alarms and errors that are related to that sub-layers. So we can do AIS alarm injection, for instance, or we can just send some beep errors. We can do it at a specific amount or do them continuously. On the TTI TX, so this is where we can, if we have any trace that we want to send, any SAPI message that we want to inject, we can do it here. The OTU RX tab, so that's for the receive end of the OTU TX. So if you have any alarm related to the OTU sublayer, so this is where it's going to be displayed. If you have any alarm, any error as well, so it's going to show us the duration, the count, and the rate as well. The TTI RX, just like the TTI TX, will show us the alarm that will show us the message that we receive on the SAPI message and the DAPI message that we receive. The ODU, the tandem connection monitoring tab menu. So if you click on that, it gives us the option that we use for doing our tandem connection monitoring. In the test, in the configuration that we have 3 monitoring points. So we can select one of those 3 and we can inject some AIS alarms, for instance, or we can do beep alarms injection. We can do them continuously at once. So this is just to send at a specific monitoring point. So we can do TTI TX inject message monitoring in here as well, just like we did it on the OTU2. And also the same thing for the TCM RX. So we can select a specific TCM level, as we did in the example. We had 3 of them, and then see if there's any alarm, there's any error that we have just at that specific point. So this is going to be applicable for one of the testing applications that we did during the presentation, where you can actually have troubleshooting. So it's a very good way of doing troubleshooting. The TTI RX for the receive end, so to see the SAPI message, the TCM, the SAPI and the DAPI message that we're receiving, those will be displayed on this tab. The ODU2 submenu is for our optical data unit sublayer. So basically this is where we inject or generate any alarm related to our optical data unit. So we can send beep errors here as well. We can do them continuously, just like we did in the OTU2 and ODU2 sublayer. The TTI-FTL, we can transmit some alarms and error on that layer, and we can also send some messages to a specific, just to see if we can get to a specific fault. So this is very useful during a continuity testing if you're doing that on our OTN layer. The ODU, the optical data unit, this is for the receive end. any alarm or any error that we have on that layer, the optical data unit layer, would be displayed on the screen. The TTI, FTL, RX, so if you have any SAPI, any DAPI message, it will be displayed here. And if you have any fault also, it will be shown on here, just like we did it. So we can inject it on the transmit and see if you can receive it on the receive end. So basically this is also very useful if you're doing a continuity test. Now on a path layer, so this is for the OPU2 submenu. So we have two tabs. So if you want to set a specific PRBS signal, we can do that here, and also a specific code. So we can set asynchronous messaging or synchronous messaging, we can do that, or we can set our multiplexing structure on our optical data unit, we can do that here for instance. And we can set it to a specific payload code. The OPU RX, the optical path unit, on the receive end, so this is if you have the PRBS that we're receiving would be displayed here, as well as the code that we're receiving. If you have any alarm on that layer, it would be displayed on this screen as well. So these are the functions and the sub-layer testing applications on the OTN layer itself. Now to go back to the testing submenu, so we click on back, and then it takes us to the testing submenu. Now we have the pattern menu that we can click. So this one will allow us to actually change our test pattern. So we were able to do that when we're doing the configuration. We can do it here. So if you have any pattern loss that we want to generate or any bit error that we want to send, so we can do it on this screen as well. The pattern RX, that's for the receive end. So it's going to show us the test pattern that we're expecting, and also if you have any bit error or any alarm pattern loss, it would be displayed here. The PM tab is for the performance monitoring, so it supports the G.821 standard, and it does the near end testing. For one of some of the defects, for instance, that the performance that it monitors is the error-free second, for instance. As we see, it's been 500 seconds that we've been running this test with no error. That's what this one shows us right here. Now let's talk about some of the tools and utilities that we have on this product. As we can see, we have some buttons at the bottom. This one, the green one to the left, is the stop and start button. That allows me to start a test or to stop a test. So right now the test is stopped. So to start it, so I just click on it again and it's going to start the test. Now the two LEDs that are to the left of that button are the H and C LEDs. The H is for the history and C is for current. So those one would change to red whenever we have a defect that occurs. So if you have any alarm or any error that takes place, the H and C would be both red. H, if we only have H red and C green, that means that we have had a defect at some point, but that defect is not taking place anymore. To the right of the start button, we have our history reset, and current reset. So basically, if you have if the LEDs, H and C LEDs are green, if you click on this one, it's going to reset the LED for the history. The 0 button is going to reset the LED for both H and C, so both of them are going to be set to green. Next to that is the alarm summary tab. So if you click on that tab, it's going to take us to the alarm summary page. As we can see, we have some new tabs that are now displayed on the screen. So it gives us LEDs with all the alarms that we have available on the test case. So the type of alarms that we have, the types that are enabled depend on the type of test that we're running, but all the alarms that would be taking, that would occur, all the errors that would be shown would be displayed on this screen. The test summary tab, right next to the alarm summary, is the test that is used to do the test configuration, that are standard. This is where you would actually put your test name, if you have any description of the test, or also if you want to set the start time, the stop time of your test, if you want the test to start at a specific time or to stop at a specific time, or if you have a duration that you have in mind. For instance, you're running a birth test and you want it to run for 48 hours, so you can count on this, select 48 hours, enable it, and then just click on the on-off button, and it's going to run a birth test for 48 hours. So these are some of the configuration that we have that we call timer configuration to set the start time, the stop time, and also duration. The test logger is actually the screen that will show us any alarm and error that takes place. It gives us the time, the duration, and also the type of test that we're running, and the type of alarm or error that we receive. The test preference tab is the tab that we use to set the default preferences for a specific type of test. So if you have any STS1 fixed stuff column that you want to set, you do it here. Or if you want, for instance, your background traffic under your OTN, if you're running OTN testing, or your SONET or STH high order path, low order path, so you can equip your background traffic, you can do that here. So the button that is right to the alarm summary button is actually the button that is used to go back to the main menu for the test configuration. Next to that, we have the bit button that actually injects a bit error. So if you click on that, it's going to inject one bit error. As we see right here, our H is red and C is green. That means we've had a 1 bit error. So if I go back to the alarm summary page, so we go back to the alarm summary, as we see here, we've had a bit error that lasted 1 second. So we can also, if you want to reset it, we can also click on the reset here. As we can see, it resetted the history, and now we have both our LEDs green. And also, if you want to reset the history on all counters, we click on the 0 and it resets everything. As we can see here now, even the counter and the rate are all set to 0. The last button on this at the bottom, the green one, is actually to turn on or turn off the laser. So if it's in green, that means that the laser is on. So if I want to turn off the laser, I click on it and it changes. So now you have a yellow inside of it and it's not green anymore. So that means the laser is off. As we can see, as soon as I turn it off, we have some loss of signal. That's because my laser is off, and also I have both my H and C LEDs red. So if I will turn it back on, now the laser is on, and now all the alarms, all the current alarms at least, are green. The three buttons right next to, the three buttons at the bottom right corner are used for the module as well. The first one to the left is used to take a screen capture. So if I click on it, it's going to take a screen capture of the screen that I'm actually on, and I can save it as a bitmap. So if I'm running a test and I just see something that occurred on the screen that I want to capture, I can just click on that and then save it on my unit, or I can save it on an external device. So as you see, I have a name here that I can type, and it's going to save it as a bitmap type of file. Now the button right to the right of that, which the question mark, is actually the one that gives us the help information. So if we have running a test and we need some help with the type of test that we're running, so we can click on that and it's going to display a text message. It's going to see, we have to select a topic and it's going to display. If we select alarm summary, for instance, it displays the message about the alarm test, the type of test that it's doing, how it works, and also the functions that we have on that screen. So it's all displayed here. So it's a very useful and tool that we can use when running a test and we're not sure about the result that we're getting. We can click on that button. The X button at the bottom right corner is actually to exit the test case. Now we're going back to the main menu again, and this time we're going to see some of the utilities also that we have on this unit. So to do so, we click on System, and then here we have the clock setup that we can do, the preferences. We can see some module information, also the software options that we have installed on the unit. So for the clock synchronization, we click on the clock sync submenu, and this is basically the function that we use, especially if we have an external clocking source that we use. So we can set on the TX portion of it, we can select the type of interface that we want to use. So as we can see, we can use a DS1, E1, or a 2 meg clocking source if we use that. And likewise, we can do the same thing for the receive. So basically, this is when we are using an external timing source. And also the reference out that we use, that 10 gig reference out. So this is also where we set it. So we can use the divider and set a specific divider type that we have. So this is basically where we have the settings for the clock for the synchronization, mainly used for the external timing source. And below that we have the preferences. So this gives us a choice to actually have general preferences for the test or the applications that we have using on this specific module. So the test time, for the test format can be set here. As you can see, we have the ISO format or the American format. And also the time zone, we can set it here. If you want a local, if you want a universal time zone setting, we can set that here. And also the test time display. We have two modes, which is the relative and the absolute mode. And also you have audible if you're using any audible for alarm and error, so we can display that here. The hierarchy, as far as the SONET hierarchy notation is concerned, if you want the hierarchy or notation, we can set it here as well. Right? The next tab is going to be the default test preferences. The settings that we have by default. For instance, if you want the laser to be on every time we start the test, by default we can set it here. If you on the STS1 fixed staff column, if you want it to be filled by default, we can do it here. And also on the background traffic, we can set the default background traffic here, as we could do also, once we configure the test case. So here the laser is on. As soon as we start the test, we configure the test, automatically the laser will be on. We can turn it off later if you want to. Right below the preferences, we have our next tool, which is actually the module information. Under the module information, we have the information regarding the software, the module itself, and the hardware options. So on the software options, these are where the versions are displayed. The module description gives us information related to the module itself, the type of module, and also the serial number. Under the hardware option, this is where we have information regarding specific transceivers that are actually being used on the module itself. As we can see right now on the screen, we have SFP and XFP because those are the two transceivers I'm using in this module. It gives us very, very useful information regarding the transceivers. So this is useful too, especially when we're running a test and we're not sure if you are using the proper transceiver. So we can come here and see the type of transceiver you're using, and then we'll know if that's actually supported by the product itself. Below the module information, we have the software options. So this is where we see all the options that we have enabled on the unit. So if you're running a test and we're not sure if that we have an option enabled, so we can come here and see all the software options that we have and make sure that the test that we run, we have the software option enabled for it. So if the option is not enabled, then maybe it's not purchased, so you can contact EXO and get the software option. And it's very easy to load. So in order to load that, make sure the test is not running, and then we just use the load key function to load the application, browse for the specific key that was sent to you by Expo, and just enable it. So it's a very quick process, it's a very quick procedure, but we have to make sure that the function that the option that we are trying to use are enabled here. Some other utilities that we have on this test case, on this module, are the ones that we use to save a configuration, to load a configuration, or to generate a report. So I'm going to stop the test. And now we're going to save the configuration that we have here. So in order to do that, I'm going to File, the File menu, and then click on Save As to save the current configuration. So I'll name it Save Test. So we can place our new configuration any location on the unit itself, or we can even put it on an external drive. So we hit OK. So now, in order to load the configuration that we saved, or any of configuration for that matter, so we click on the Open sub-menu and then select the configuration that we want to load. So I'm going to select the configuration that I just saved, and I hit OK, and it's going to clear the existing configuration and load the new configuration that I just chose. Now we see on the screen it displays a diagram of the configuration that we just loaded. The next tool that we have in the same menu is our reporting tool. In order to generate a report, we use that tool. So we click on Report, and this will give us a window where we can actually put some useful information. There are two types of report that can be generated. There's a report that can be viewed on the unit itself, which is called a compact report. In order to get that, we go to the report type drop-down menu, and we select compact report. And we also have what we call a full report. The full report is used to generate the complete report of the test that we just ran. In order to view that, however, we have to use another software that we call the external report generator. That software has to reside on the PC or the laptop that you're using. So this is actually a two-step process. First, you have to generate the report on the unit, and then it's going to create a file with an RXML extension. Then you take that file, you put it onto your laptop or your PC. With the external report generator, you load that file and then generate and view the full report. So the compact report, we're going to choose that, and then we're going to view the report after generation. Now let's click on Generate, and then let's choose a name for the file we want to generate is under. So this is the file name that it's going to use. So it's going to save this report as a text file with the name that we just selected. So the next time we want to view that report, we can use the unit to do so, or we can even put it on a PC or laptop just using almost any editor, because it's just a text file. As you can see, this is the compact report. It gives us the basic information of the test that we just ran. As you can see, it gives us the pattern and also some of the alarms and the errors that we have while we're running the test. So basically, the very fundamental and basic information would be displayed on this report. So we can close this and return to our main screen. So this is the first type of report that we can generate. Now the second type of report, as I mentioned earlier, is actually the full report. As we can see at the bottom, we have a report type, we have compact report. If you click on the drop down menu, we also have a full report. So we choose full report, and then we click on the generate button, and we are going to generate the full report this time. So we select a name, so and now we save it, we hit OK. So as we see, we just created a file with an RXML extension. So this is the file that we need to use on our PC or laptop with the external report generator that we have installed on it to actually generate the full report. So the file by itself is not going to be any useful for us. We have to use it with the external report generator that is installed on the PC or the laptop that we want to use to generate the report. So these are some of the basic tools. And also we have the About submenu that we can use. That's going to give us just some basic information regarding the product. As we see, we have some useful information as contact info for Expo, and also the software version that is actually run on the unit. It also tells us the type of unit we use, the type of module that we're using, and also the serial number of the unit. This concludes our multimedia training for the FTB81XX module. If you have any questions, please feel free to contact Expo Technical Support Team using the information displayed on the screen. Thank you.